Hello and welcome to Guided Notes with Mr. Weeb. Today we are looking at representing the subtraction of fractions. And the goal is for you to be able to say, I can use models to show how to subtract fractions even when the denominators are different. So make sure you've got your pencil ready to go. You've got your earbuds in so you can hear my voice, and let's get going. When to subtract. The first situation that we'll talk about, which most of us are very familiar with, is when something is taken away. Then you can use subtraction. For example, you have 2/3 of something, and you used up 1/4 of it. How much is left? The expression you would use is 2/3 minus 1/4 to get your answer. Another situation when you could use subtraction is when two amounts are being compared. So how much more does 2/3 of a container hold than 1/4 of a container that is the same size? The mathematical expression we can use is 2/3 minus 1/4, and that would find the difference between those two amounts. Another one is when you have to decide what to add to one amount to get another. So for example, how much more do you need to add to 1/4 cup of something to have 2/3 cups in total? Again, you would say 2/3 minus 1/4, because this is like saying, how much do I need to add to 1/4 to get 2/3? Next, I'll demonstrate for you how to subtract fractions with fraction strips. We do have fraction strips on paper in the classroom, but we also have access to iPads and computers, and that's what I'll show you here. The one we're going to use is on mathsbot.com. So go to mathsbot.com, and when you're there, you can see there is manipulative section right here. So that's what I'm going to ask you to click on. And when you go there, you're going to have lots of options, but the thing we're looking for is the fraction wall right over here. So you're going to click on the fraction wall. And I would recommend using, instead of a denominator of 8, I would go to 12 and then use the stack. So let's look at that, changing to 12 and stacking it. You just have more room. Now we're asking 1/3 minus 1/4. So let's get 1/3 out here, and let's get a 1/4 out here. Remember we said when we're comparing two amounts, we can use this, right? Or when we're adding, how much would we have to add to 1/4 to get to 1/3? So basically we're saying, what is in this gap? What could fill this space right here? And with this manipulative, you can try out some different things. Would 1/10 work? Oh, no, it's too big. Let's get rid of that one. Would 1/12 work? Aha, there it is. So now we know that we can, when we're doing this, 1/3 minus 1/4, well, that is 1/12, just like that. Let's look at the next one. Subtracting fractions with what you know about numbers. What is 4/5 minus 1/2? To use this method, it's helpful to think of a number that can easily be split up into 5 equal parts and 2 equal parts. And the first number that comes to my mind is 10. So if I have 10 and I split it into 5 equal groups, then I get 2. So that means that 1/5 of 10 is going to be 2, right? And then if I need 4 of those, 4/5 of 10, we just need to count 4 of those. So 4 of those are going to be 8, right? 1/5 is 2, 2/5 is 4, 3/5 is 6, 4/5 is going to be 8. Then, when we talk about a half, we can talk about how half of 10, we can split 10 into 2, right? 10 into 2 equal groups is pretty simple. It's 5. So that means that half of 10 is going to be 5. That's it. Okay, and now we can just say half of 10, or sorry, 4/5 of 10 minus half of 10. So 4/5 of 10 is 8, minus Half of 10, which is 5, is going to give us 3. And since we're talking about tenths, the whole is 10, then our answer is going to be 3/10. Next, let's talk about subtracting fractions with a grid. The first way we look at this is subtraction by taking away. So we'll start with 2/3 of this shape full, and then we'll take away 1/5. You'll notice that we set this up so that we have the shape split into thirds, 3 rows, and fifths, 5 columns. Okay, so let's put in 2/3 here. That's 1/3. There's 2/3. Okay, so that is 2/3. Next, we're going to take away 1/5, but it's hard to take away 1/5 if we can't see what 1/5 looks like. So let's rewrite this. Let's redraw it, but move one of the circles. Instead of filling up both of those rows, let's make sure at least one column is filled, so that when we take away 1/5, we know what that's going to look like. That's going to equal, when we take away these 3 and redraw it again, it will look like this. How many dots do we have? Well, we've got 7. Out of how many total possible spots? There are 15, so this is the final answer. Finally, we can think about it more as thinking about how far it is, or what would we need to add to 1/5 to get to 2/3. So here is 2/3. Well, let's highlight them in blue and red so that it's easy to tell. And let's make 2/3 over here. So here's 2/3. Here's 1/3, and then 2/3. And we're going to see how far is it from 1/5 to 2/3, right? What would I have to add to this to get this many dots in there? Well, I can see if I started with 1/5, which is just 3 of these dots, how many more would I have to add? I would have to add 1, 2, 3, 4, 5, 6, 7. To explain this grid, I would say something like this. There are 7 more counters in the first grid, so the difference is 7/15. And that is your answer. That's it for today. Thanks for watching.